IEEE Standard 43, titled Recommended Practice for Testing Insulation Resistance of Rotating Machinery, offers guidelines for using a megohmmeter to test rotating machinery, including motors. This standard helps in assessing the condition of the motor's insulation. When performing megohmmeter tests, IEEE Standard 43 provides recommended minimum readings for motors. For new motors at room temperature, the recommendation is 1 megohm per kilovolt of rated voltage for phase-to-phase measurements and 0.5 megohm per kilovolt of rated voltage for phase-to-ground measurements. For motors already in service, the minimum values remain the same, not less than 1 megohm per kilovolt for phase-to-phase and 0.5 megohm per kilovolt for phase-to-ground. It is important to understand how to interpret these readings. A reading of 1 megohm to ground on all three phases of a 20 horsepower, three-phase motor may be below the recommended minimum value of 0.5 megohm per kilovolt of rated voltage, but whether this value is acceptable depends on the motor's specific design and operating conditions. Several factors can influence insulation resistance readings. Firstly, temperature plays a significant role. Insulation resistance decreases as temperature increases. Therefore, it's important to record the temperature at which the test is performed and correct the readings if necessary. Secondly, moisture can significantly reduce insulation resistance. Ensure the motor is dry before testing and note any signs of moisture contamination. Thirdly, the age and operating history of the motor affect insulation resistance. Motors that have been in service for a long time or have been subjected to harsh conditions may naturally have lower insulation resistance. To determine the rated voltage of your 20 horsepower, three-phase motor, you will need to check the motor's nameplate. The nameplate will list the voltage or voltages for which the motor is designed to operate, such as 208 volts, 230 volts, 460 volts, or 575 volts. Once you have the rated voltage, you can calculate the minimum acceptable insulation resistance according to IEEE Standard 43. For example, if the motor is rated for 460 volts, which is 0.46 kilovolts, the minimum acceptable insulation resistance to ground would be 0.5 megohm per kilovolt times 0.46 kilovolts, which equals 0.23 megohms. This means that your reading of 1 megohm to ground is higher than the calculated minimum of 0.23 megohms for a 460 volts motor based on IEEE 43 recommendations. However, remember that this is just a general guideline, and other factors may still affect the health of the motor's insulation. When you get a reading, compare it to past readings for the same motor, if available. A sudden drop in insulation resistance is a greater cause for concern than a consistently low reading. Also, consider the environment in which the motor operates. Motors in humid or dirty environments may have lower insulation resistance readings due to surface contamination. Clean the motor and retest to see if the readings improve. If you have concerns about the low megohmmeter readings, consulting an experienced electrician or motor testing specialist is recommended. They can perform a more thorough evaluation and determine if the readings are acceptable or if further testing or maintenance is needed. An electrician may perform a polarization index test. This test involves taking insulation resistance readings at two different times, typically 1 minute and 10 minutes, and then calculating the ratio of the 10-minute reading to the 1-minute reading. A higher polarization index indicates better insulation quality. Another test an electrician may perform is a dielectric absorption test. This test involves applying a constant voltage to the motor windings and measuring the current over time. A healthy motor will exhibit a decrease in current as the insulation becomes polarized. If the current remains high or does not decrease significantly, it may indicate insulation problems. If the motor's insulation resistance is below the minimum acceptable value, several actions can be taken. Firstly, cleaning the motor windings can remove dirt, dust, and other contaminants that may be reducing insulation resistance. Use a vacuum cleaner or compressed air to remove loose debris, and then clean the windings with a non-conductive solvent. Secondly, drying the motor windings can remove moisture that may be affecting insulation resistance. This can be done by placing the motor in a warm, dry environment or by using a space heater to gently warm the windings. Be careful not to overheat the motor, as this can damage the insulation. Thirdly, applying varnish or epoxy to the motor windings can improve insulation resistance and protect the windings from moisture and contaminants. This is typically done by a motor repair shop. To ensure accurate megohmmeter readings, it is important to use the correct test voltage. IEEE Standard 43 recommends using a test voltage that is approximately twice the motor's rated voltage, but not exceeding 5000 volts. For example, for a 460 volts motor, a test voltage of 1000 volts would be appropriate. It is also important to discharge the motor windings after performing the megohmmeter test. This will prevent electrical shock and protect the motor's insulation from damage. Use a grounding stick or discharge resistor to safely discharge the windings. When using a megohmmeter, it is important to follow all safety precautions. Wear appropriate personal protective equipment, such as gloves and safety glasses. Ensure that the motor is de-energized and locked out before testing. And never touch the motor windings while the megohmmeter is connected. Remember that megohmmeter testing is just one tool for assessing the condition of a motor's insulation. It is important to consider other factors such as the motor's operating history, environment, and visual inspection when evaluating the overall health of the motor. It is important to keep detailed records of megohmmeter readings over time. This will allow you to track changes in insulation resistance and identify potential problems early on. Regular megohmmeter testing can help to prevent motor failures and extend the life of your motors. Finally, remember that motor maintenance should only be performed by qualified personnel. If you are not comfortable working with electrical equipment, consult an experienced electrician or motor repair shop. Regularly inspect motors for signs of damage, such as cracks, loose connections, and corrosion. Repair or replace damaged components as needed. Keep motors clean and dry. Remove dirt, dust, and moisture regularly. Lubricate motor bearings as recommended by the manufacturer. Over-lubrication can also be harmful, so follow the manufacturer's recommendations carefully. Monitor motor operating conditions such as voltage, current, and temperature. Investigate any unusual readings or changes in operating conditions. By following these recommendations, you can ensure that your motors operate reliably and efficiently for many years. Remember that safety is always the top priority when working with electrical equipment. Always follow proper safety procedures and use appropriate personal protective equipment. If you're unsure about something, consult a qualified electrician or motor repair shop. Understanding the principles of insulation resistance testing and IEEE Standard 43 can help you make informed decisions about motor maintenance and troubleshooting. This knowledge can save you time, money, and prevent costly motor failures. Always refer to the latest version of IEEE Standard 43 for the most up-to-date information and recommendations. The standard may be updated periodically to reflect changes in technology and best practices. Consider attending training courses on motor maintenance and testing. These courses can provide you with the knowledge and skills you need to safely and effectively maintain your motors. When selecting a megohmmeter, choose a model that is appropriate for the voltage rating of your motors. Ensure that the megohmmeter is calibrated regularly to ensure accurate readings. Use high-quality test leads and probes. Inspect test leads and probes regularly for damage. Replace damaged test leads and probes immediately. Before performing a megohmmeter test, visually inspect the motor for any signs of damage or contamination. Look for cracks, loose connections, corrosion, and excessive dirt or moisture. If you find any problems, correct them before proceeding with the test. Disconnect the motor from the power supply before performing a megohmmeter test. This will prevent electrical shock and protect the megohmmeter from damage. Discharge any capacitors in the motor circuit before performing a megohmmeter test. Capacitors can store electrical energy even after the motor is disconnected from the power supply. Ground the motor frame before performing a megohmmeter test. This will help to protect you from electrical shock. Connect the megohmmeter test leads to the motor windings and to ground. Follow the manufacturer's instructions for connecting the test leads. Apply the test voltage for the specified time. IEEE Standard 43 recommends applying the test voltage for 1 minute. Record the megohmmeter reading. Note the temperature and humidity at the time of the test. Compare the megohmmeter reading to previous readings and to the recommended minimum values in IEEE Standard 43. Analyze the megohmmeter reading to determine the condition of the motor's insulation. If the megohmmeter reading is below the recommended minimum value, investigate the cause and take corrective action. After performing the megohmmeter test, disconnect the test leads and discharge the motor windings. Store the megohmmeter in a safe and dry place. Keep the megohmmeter clean and in good working condition. Regularly inspect the megohmmeter for damage. Replace any damaged parts immediately. By following these best practices, you can ensure that your megohmmeter tests are accurate, safe, and effective. This will help you to maintain your motors in good working condition and prevent costly failures. Remember that motor maintenance is an ongoing process. Regular inspection, testing, and maintenance are essential for ensuring the reliable and efficient operation of your motors.